Distance learning is a phenomenon that comes to the mind, especially when it is difficult or impossible for people to come together for educational purposes. It also makes learning independent from the classroom environment. The COVID-19 epidemic, which covers the world in last year, has led to these approaches of distance learning through new digital technologies and has revealed the need for more effective and efficient education models with interdisciplinary concepts. The fact that distance learning is independent from the classroom environment directly affects the student's interest and interaction in the lesson. In face-to-face learning, the interaction between the teacher and the student has not only cognitive, but also emotional and physical factors. Lack of these factors in distant learning has negative consequences, especially in learning and experimenting processes. Many different models and methods have been developed for distance learning so far. These models were mostly provided by adapting traditional methods and educational contents to existing technological tools, and unfortunately did not bring an effective solution proposal to the specified problem. Extended reality applications, which are considered as an exciting technology today, also offer great opportunities for distance learning. Various models have been proposed to use these technologies in distance learning, which provide ideal tools for both spatial and interpersonal interaction with virtual and augmented reality. In this study, the asset-based extended reality model was proposed as an alternative to the other models and compared by using quantitative data. The model has three pillars: assets, gamification, and immersion. Technology facilitates our lives while providing more efficiency with less cognitive effort. Therefore, the use of technology, especially in the field of education, is an exciting subject for everyone. The physical world is blending with virtual content, and people are living in an extended space enhanced through digital technologies. With the growing impact of digital content, the experience of learning and teaching in higher education is being changed significantly. Emerging VR and AR technologies for the first time offers an authentic, hyper-immersive learning experience in a technically feasible format for a large cohort teaching at a decent price. The intervention of multiple elements such as 3D models, animation, graphics, and audio display in a technology-integrated learning environment is crucial. The fusion of 3D models, animation, video, and graphics with the addition of text and audio can enhance the understanding of the content. Salzman describes three promising features of VR for learning: three-dimensional immersion, multiple frames of reference, and multisensory cues. For VR education, Boomsdorf makes a distinction between a digital learning space and a digital learning context. A digital learning space comprises the particular digital exercises undertaken by a learner, where the context refers to a broader set of circumstances through which sense-making and fundamental understanding are formed. The blurring boundaries between learning space and context challenges many established theories of learning. The most significant impact of VR on learning may not be about the technology itself at all, but rather the radically different potential configurations of learning space and context that VR tends to promote. Kolb's experiential learning model is a learning way that is about approaching life experiences with a learning attitude. The experiential learning model is a learning way that is about approaching life experiences with a learning attitude. Concrete experience is a doing or having a new experience or situation which is encountered, or a reinterpretation of existing experience. Reflective observation of the new experience is stepping back from the task and reviewing what has been done and experienced. Abstract conceptualization is the process of making sense of what has happened and involves interpreting the events and understanding the relationship between them. This gives rise to a new idea or a modification of an existing abstract concept. The person has learned from their experiences. Active experimentation is using theories to solve problems and make decisions. Here the learner applies their ideas to the world around them to see what happens. Huang and Du proposed an English learning VR game based on the APT model. In their research, the APT teaching model contains three aspects: assessment, pedagogy, and technology. Their model is mostly built on the pedagogical aspects of learning, while it is supported by technology and assessments. In the pedagogical aspect, the model analyzes the students' teaching goals, design of teaching contents, and design of the teaching activity. The model also considers the design of both teaching contents and activities while expressing the teaching key points as tasks, challenges, and teaching activities as a role-playing and game-based task-driven approach. In the assessment aspect, the model emphasizes both formative and summative assessment, where the system offers feedback and helps the students to achieve the tasks. In the technology aspect, which covers the equipment and instructions, including the usability of tools as functional design elements, interface design elements such as learning cards, real-time feedback, and navigation are crucial elements of a successful learning experience. This multidimensional model proposed by Prevenu, Balog, and Iordake is depending on the technology acceptance model, which is developed by Davis, who explains user acceptance in terms of perceived ease of use and the perceived usefulness. This model was further extended to include the perceived enjoyment. The conceptual model has three dimensions: perceived ergonomic quality, perceived learning quality, and perceived hedonic quality. And also, in return, each dimension has two subdimensions. The first concept of the model is perceived ergonomic quality, and it has two facets such as ease of learning, how to use, and ease of use, where learnability refers to the ease of understanding, learning, and remembering how to use an application. Perceived learning quality has also two facets, as perceived efficiency, which is distinct construct pointing to a better and faster understanding, and perceived usefulness as improvement of knowledge, usefulness for testing knowledge, and support of learning. The third and the last concept of the model is the perceived hedonic quality, which also has two facets, as cognitive absorption, which is the state of total engagement when the attention is focused on the interaction with the application, and perceived enjoyment refers to the enjoyable experience within the application. In recent years, there has been a vast interest in discovering how computer and information technology influences, motivates, and persuades people to change their behaviors and attitudes. Known as persuasive technology, it promotes an interactive technology that can change a person's attitudes or behaviors. As presented by Zulkifli, IPL model is based on three broad categories: interactive media features such as layout and consistency, simulation, navigation, and minimal input device, interactive persuasive elements such as motivation, experience, cognitive and emotional appeal, and learning outcomes such as performance and satisfaction. In this model, the four interactive media features are the interface, as layout and consistency, the simulation, which can be simple 2D or complex virtual 3D, the navigation, and minimum input devices as usability factors. The effects of interactive media features are categorized as motivation, experience, cognitive and emotional appeal for learning activities. Motivation leads to positive performance outcomes. Cognitive is understanding the learner's thought processes. Emotional appeal is the aesthetic approach to the design with human emotions, affects, feelings, and mood. And finally, the experience is about the learning process. As learning outcomes, Zulkifli puts performance and satisfaction as the end of the learning processes. It is about recognizing the changes in knowledge and the feelings after learning with interactive media, which may have an impact of persuasion. After examining the different training models applied in the previous section, we searched for a much more efficient model for XR. The main reason for this was that the existing models did not bring enough XR opportunities and advantages to the fore. However, it was an important criterion to include innovations offered by developing technologies within the model. We set the three pillars of the model as a target for Kolb's learning styles and for a sustainable flow in itself. According to Kolb, four learning styles are accommodating, divergent, assimilating, and convergent. Different learning styles would impact learning outcomes. Divergent learners can explore a range of observations and generate many ideas. Assimilating learners transform learning experiences into abstract concepts. Converging learners evaluate and refine ideas and theories for a better practical uses. And accommodating learners conduct hand-on activities. Addressing all of Kolb's learning styles on three pillars, the asset, gamification, immersion model has been developed to create an efficient and balanced structure, especially in XR applications for educational purposes. The model, which is built under the main headings of assets, gamifications, and immersion, also includes technology, content, and experience subtitles in the learning cycle. Assets are the resources that are used to deliver information for training and development. Learning assets facilitate mental exercise, and it varies from passive to active learning processes. In the XR learning model, digital learning assets have transformed from tangible objects such as books and manuals to mobile apps, video streams, and much more. In XR, video and audio content is much more dominant than the textual sources. The reason for using gamification in education is the element for motivation it provides. Different game mechanics are used to motivating the person about the work they are doing. The most obvious of these mechanics is leveling up. Just like it is in real life, as a person fulfills certain achievements while doing their work and subsequently go into an upper level in their career. This is true in the mechanics of gamification itself as well. Motivation is among the important predictors of student academic achievements, which influences the effort and time a student spends engaged in learning. Games are known to increase motivation, and different educational models under the guise of gamification have seen much support in certain places. Immersion is usually defined as the degree of involvement with something. Brown and Cairns identify 3 levels of immersion in games. The first is engagement, which is when the interest and desire to keep playing is sufficient to justify the time and the effort needed to learn how to play the game. The second level is engrossment, a feeling of emotional attachment that makes people want to keep playing and can lead to people feeling emotionally drained when they stop playing. The third level is total immersion, a state in which players are cut off from reality and the game is the only thing that matters. The relationship of distance learning with students' environment will be more effective with a virtually created or enriched spaces. Immersion takes place right in front of the student's eyes, not just as visual effects, but also as cognitive isolation from reality. The content area covers all topics and approaches covered by XR learning model. Since the XR pieces of training are spread over a very wide area, an interdisciplinary perspective has been developed here. Of course, especially the advantages of XR education over traditional education systems are highlighted and the issues that cannot be presented in real life in terms of content are evaluated. In the next generation of education, it is inevitable to handle more inclusive and experience-based educational content as well as current curricula. Experience-based training brings with it numerous tasks and process management. These tasks and processes provide important data for the measurement of education success and can update the system according to the learning speed of the students. It is much more possible to create an individual approach and tailored curriculum scopes in education compared to traditional systems. In this case, a more flexible content structure can be formed spontaneously according to both students' learning speed and manual skills. Although lesson content is prepared in different areas, the pedagogical approach is the same in terms of necessity of preparing the subjects with a specific learning ease scheme. The technology field aims to address and apply all existing XR technologies within the scope of the model. It follows the developments especially in immersive media technologies and keeps itself up to date by catching possible opportunities and challenges in classroom use. Education, above all, involves a collaborative social structure. Learning action never means to isolate students from the learning environment and social interaction. So the inclusion of social and extracurricular personal skills within the curriculum will bring positive results in terms of the efficiency and impact of education. One of the most basic topics of experimental learning aims to transform students' theoretical knowledge into maximum practice, especially the structure that constructs the different stages and processes of the experience with the logic of game mechanics aims to make the student master of the subject both theoretically and practically. Enjoying while learning is an important factor that increases permanence after learning. It is expected that the content and the experience will be prepared in a way to provide maximum pleasure, especially in the process of gamification of educational content. Usability is always at the forefront of XR training. The students should be able to play not only the game, but also the system easily. When user experience is good, user interaction contributes to immersive experiences. When user experience is bad, the user interaction with the machine results in frustration and disruption. Properly designed, the graphic user interface of a game should make it easy for learners and to interact with the game. The most essential criteria to keep the immersive learning experience at the maximum level are the continuity of the learner's interest and the sustainability of the concepts learned. To achieve these, it is necessary to focus on educational content, presentation style, and outcomes. As a result, a process-based assessment should be made to internalize the student's experience, customize it according to their abilities and skills, and ensure that they follow their progress. According to Rater, attention is more than just noticing incoming stimuli. It involves several processes including filtering out perceptions, balancing multiple perceptions, and attaching emotional significance to these perceptions. Learning outcomes are statements that describe the knowledge or skills students should acquire by the end of a particular assignment, class, course, or a program and help students understand why that knowledge and those skills will be useful to them. With XR, it can be easier to get the results of learning outcomes compared to classical education. The feedback of the learning experience, especially in the gamification process, supports the visibility of these outcomes. One of the most important criteria of the model is also how far the topics learned can be applied in real life. Especially the closeness of simulative training to the real world is of great importance in terms of continuity of experience. The most important challenge of the new technologies is to adapt them to education systems and get maximum efficiency from them. The main reason for this is those existing systems and those who use them do not give up the methods and exercises they are used to easily. The immersion afforded by effective educational games has implications for the engagement and the learning that students experience. Higher levels of immersion are likely to make students more engaged in their learning, which can then lead to greater learning gains. Starkey states that current challenge for teachers is to convert established learning theories into new practices that most effectively leverage and engage the upcoming digitally literate generation. XR technology is itself still under development, and neither the definition of the VR nor the particular implementation of the technology is stable. According to Wang, educators are more likely to focus on technology use rather than thinking about the underlying pedagogical problem. The variety of the educational themes included in XR learning exposes a huge need for content creation based on the virtual simulations. This is both digital assets such as 3D models, animatics, visual effects, simulations, and conceptual assets such as storytelling, navigation, and flow. With the AGI method, we aim to show that a system where different disciplines are synthesized together, much more accessible and sustainable education curricula are created, and the learning experience of the student is made more effective and enjoyable.